Okay, so let's continue with our note taking, our note making here. Okay, the span on the input side is 20 minus 4, and that's equal to 16 milliamps. Output side, span is equal to 15 minus 3 is equal to 12 psi. All right. Now then, I think I will stop there for the moment. My wife is waiting for me to go out to lunch with her, and I will continue when I get back. So, with this we see that our span is the distance from here to here. Now, the reason we're having this discussion is that we have in process control and among the instrumentation devices, we have what we call proportional relays, okay? A proportional relay is a device in which I can put a signal of one type, such as milliammeters, into the device as my input, and the output could be in pressure or it could be in temperature or a flow rate. So what I like to do is I like to draw our span line vertically. Okay. And then we will put the, or at least I do, put the upper range value here. So this is the upper range value for input, upper range value for output, and now I need my lower range value. Okay, so upper range value, and that's for the input, upper range value for the output, lower range value, again for input and output. Some of the signals that we have, in fact a lot of the signals that we use, do not start at 0. My favorite example, which we've discussed in class, is the 4 to 20 milliamp signal, okay? And later we'll discuss why that is so popular. And for the output, we have been using the example of 3 psig to 15 psig, which is another popular range. Now notice that I used 2 numbers because it was the range. Okay, so let's continue with that. So this is our input on this side. Output is on this side. And the input lower range value was 4 milliamps, and the upper range value was 20 milliamps. Output side, upper range value is 15 psi. Lower range value is 3 psi. Okay, so for the input, the span is 20 minus 4, so the span is 16 milliamps. On the output side, upper range value is 15 psi, the lower range value is 3 psi, so that has a span of 12 milliamps. Okay, so let's continue with our note taking, our note making here. Okay, the span on the input side is 20 minus 4, and that's equal to 16 milliamps. Output side, span is equal to 15 minus 3 is equal to 12 psi. All right. Now then, I think I will stop there for the moment. My wife is waiting for me to go out to lunch with her, and I will continue when I get back. Okay, so we've set up our range spans. On the input is on the left side, output is on the right side, right? And this span is 16 milliamps, and this span is 12 psi. Now then, we'll put a slider in here. Okay, so the way the instrument is designed is wherever my input signal, wherever it resides on the scale up and down, the output signal stays right with it. Okay, so if I take this slider and I push it all the way to the top, or all the way to the URV, the output goes with it and stays with it exactly. If I put my finger on the slider, bring it down to the LRV, then the output comes all the way down to the bottom. So if I had my slider on 4 milliamps, then my output would be on 3 psi. If I had my slider on 20 milliamps, then the output would be at 15 psi. So if it's somewhere in between, you can determine the output by doing a ratio of all the spans. Okay, and yeah, that will give you a correct answer simply by doing that. So, if you don't mind, we'll take and we'll do this. Boy, I do need a straight edge, do I not? This is the span of the signal. Okay, and this, let me try to do that a little bit better. See if I can make myself a little bit neater. Okay, so notice how neat the output is compared to the input. This is the span of the output signal. Okay. So there you have it. Now then, let's see if I can do this work on this board. and still have it neat. Okay, so remember that the span of the input range, right, is equal to the upper range variable minus the lower range variable. 20 minus 4 is 16 milliamps. The span of the output range is 15 minus 3. So those are my range spans. Range span, signal span, where whatever that number is, okay, and the output signal span here. So normally what we do, the problem that we normally find ourselves with is we know what the signal value is, we know what the input is, but we have to determine what the output is. So if you've got that down, let me find an eraser here, and let me see how much room I have on my drawing board. So what I'm going to have here, let me look around and see where my cats are first, because I've got one up here on top of a cabinet that's going to jump down on my whiteboard if I'm not careful. Okay, that was him that just jumped, but he didn't land here. So, what have we got? What colors do I have? Oh, I've got a green over here. Let's try that. So let's work with this side right here. And let's see what I've got here. If I had a sheet of paper, that would work well. I don't have one handy, so we'll tough it. That's what we'll do. So what we're going to say here, all right, let's look at the left side. I've got a fraction. So we'll say that if I look at that, the signal span over the input range span will be equal to the output see, I'm running out of room there, so let me come back this way. Output signal span divided by the output range span. And that's the basis for your ratios. Okay, so signal span is this length right here. Input range span is the distance from here to here. On the output side, the output signal span is the distance from here to here. And the output range span is the distance from here to here. So if you have one unknown in this ratio, this set of ratios right here, you can solve for that unknown. We'll continue on to the to the next video, a short one.